worksheet last night had pretty much one of each type for you to work on. So there was the distinct linear, meaning the denominator factor in each factor was different. There was the repeated linear, and that was like numbers 3 and 4, where you had like the x squared, but you had to write it as an x and then an x squared. So it's a linear factor, but it's repeated. There was a quadratic and a linear, that was number 5 on the homework. And then the last one would be a repeated quadratic, which was number 6. So each one of those focuses on the denominator and how you like separate into partial fractions. So the last type of fraction to look at is called an improper fraction. And I just want you to like think about what an improper fraction means if you have a number. So you don't have to write this down anywhere, but just kind of thinking about what improper means, taking you back to like 5th grade. If you have the number 8 divided by 5, that is considered an improper fraction because the number on top is bigger than the number on the bottom. How would you go about making that a mixed number? Brandon?
You see how many times 5 can go into 8, and then put 1 next to it, and leave the remainder over 5.
Exactly. So how many times does 5 divide into 8? Well, that's a 1. So that number gets pulled out separate from the fraction. And then he said the remainder is how much is left out of 5. Well, 3 is left after you divide. So that's how you take an improper fraction and make it into a mixed number, numerically. And we don't usually use mixed numbers anymore. We keep most of our fractions improper. However, when you're decomposing, our goal is to break it down into the original problem before you find least common denominators and combine them together, which is actually what I'm teaching on Friday in my Honors Algebra 2 class. So you guys learned this last year in chapter 8-5, pretty much this week, last year, a whole year ago, and now we're doing the exact opposite. So kind of like full circle moment here. You pulled them apart, we're putting them back together, and now we're doing that improper part. So what does it look like if you have an improper fraction? What would the beginning piece look like? So we're still going to divide, just like Brandon said, but instead of having a 5 in the denominator, we have x squared plus x minus 2. The part that we need to break down is the x cubed minus x plus 3. So essentially we're saying how many times does x squared plus x minus 2 go into x cubed minus x plus 3? Because our goal is to get the number on top, or the exponent on top, to be less than the exponent on the bottom. Long division is the way that we're going to work through it because you cannot use any other type of division. Synthetic division was the shortcut way that we learned, but that shortcut way only works if you're dividing by something that's linear, and we're not dividing by something that's linear. So the dividend is actually what's on the top of the fraction for this problem because that's the part we're trying to break down. So the bigger part goes underneath, the x cubed minus x. I'm going to actually put a 0 in here for x squared, since there's not an x squared, minus x plus 3. So this takes you way back to chapter 2. The divisor is what we're dividing with. That goes on the outside, and that would be the x squared plus x minus 2. So the bigger part should go underneath, the smaller part needs to go outside, because we're trying to break down the larger part. Libby, do you remember how long division works?
I think I do.
Okay, what do you think?
Don't you take the, like, it would be the x squared,
Mm-hmm.
and, pieces go.
Okay, Brandon?
You look at the x squared and you see what times x squared gets x to the cube. You work with the first one,
Right.
so you multiply by x.
Good. So you're only worried about the first term, nothing else. So you have an x squared. What do you multiply x squared by to make it x cubed? And it's just an x. So I'm going to place that x on top of where the x term is underneath. And then you take that x on top and do what with it? Chelsea?
Multiply it by the whole thing.
Yeah, multiplied by that whole thing. So the other pieces end up affecting the problem, but not that first step. So we're taking x times x squared, x times x, and x times negative 2. So whatever you're placing on the top, you're multiplying the divisor by that term. And then, Chelsea, what do you do with these two quantities?
You subtract them.
Right, you subtract them. So just be careful with that minus sign. Everything is subtracted. So we're subtracting x cubed, we're subtracting x squared, but the negative 2x turns into a positive 2x. And then Chelsea combining them together gives you
Negative x squared plus x.
negative x squared plus x. So just be careful, you're making sure those signs go all the way through. So then you do the process again. We'll bring down the next number since one canceled, pull the next one down. And you ask yourself the same question. Michael, we have an x squared, we want to make it a negative x squared. Now multiply by negative 1, so now we have negative x squared, a negative x, and a positive 2. And again, everything is being subtracted. So now I have a plus x squared, a plus x, and a minus 2. Be really careful with your signs. Virginia, what's left when we combine them together?
Just 2x plus 1.
Yeah, 2x plus 1. Okay, so Brandon said you take the 5, see how many times it goes into 8. The number of times it goes into that value goes in front. That's the 1. In this problem, the number of times x squared plus x minus 2 goes into our original value is x minus 1. So that's the number that goes in front. So we have an x minus 1. In addition to that, we have a remainder. That remainder was 2x plus 1, which here's our remainder of 3, out of whatever we divided by. Well, we divided by x squared plus x minus 2. So the portion that was pulled out is the x minus 1. And then the remaining part, your remainder over your divisor. So what do you think we're going to break down? Because we didn't do any like partial fraction decomposition yet. We just did long division. Michael? Yeah, that fraction part. So this leftover fraction is our proper fraction, and that's the part that we're going to decompose. Now the good thing is, the decomposing part's really easy because you just went through the whole long process of dividing, and what you have left once you factor the denominator is a linear, distinct linear, so it's going to be pretty straightforward for us to break this down. So take that 2x plus 1. Michael, how would the denominator factor?
Into the x plus 2 times x minus 1.
Yeah. Okay, so step 1, factor the denominator. Step 2, once the denominator is factored, split it into those separate pieces. Each factor creates a separate denominator. So x plus 2, x minus 1. Virginia, what goes on top of those denominators? What goes in the numerator? Yeah, just an a and a b, because these are linear. They're not quadratic. So I only have 2 variables, which means you should only have 2 equations, which is pretty easy to solve for, considering number 16 had 4 variables and 4 equations, or not number 16, number 2. So using the least common denominator, we have 2x plus 1. Cade, what would that expression be if you multiply by the least common denominator? What do you have? Ax plus,
Minus a.
okay,
Bx plus 2.
right, bx plus 2. So the next step would be to pair your values together. Get the x coefficient with the x coefficients. So x coefficient of 2, x coefficients a plus b. Take our constant value of 1, place that equal to the constant values of negative a, and I missed my b back here, and 2b. So the partial fraction part is pretty straightforward. You have 2 linear factors, 2 variables. Eris, if you add these equations together, what do you get?
B equals 3b.
So b is equal to
1.
and then a is equal to
1.
1. Questions? So what's your answer look like? Sabrina?
Is it x minus 1 plus 1 over x plus 2 plus 1
So we have that one piece that we factored out, that x minus 1. You don't have to group that together in parentheses. You could, you don't have to. So that was the piece that we pulled out using long division. Technically, we factored. And then the other two fractions that we decomposed, so we got those other two fractions, 1 over x plus 2 and 1 over x plus 1. So on Friday and probably Monday of next week, this would be where my honors algebra 2 kids are going to start. We'll work through getting common denominators, combining it all together to get the end result of where we started this time. So if you'd like to join me first period next week or on Friday, feel free. You can skip Mr. King's class. Kate and Kate can come down. I don't know what you're doing in this class.
I'm gonna move that to Monday for the TWA.
Oh, sure, we can make that work. Questions? What do you think of partial fractions? Better than trig? I have a couple kids who really like trig though. Yeah. Not you. So today, the review that I have are mostly even problems in the book. So 3 problems on page 500. You now have to check for improper fraction. So that's like the first thing to look at. If you forget that part on the test, the whole problem is wrong. So you gotta make sure you're checking for the proper versus improper fraction. My book is open over there. Both books are open. So 3 problems on page 500. You might already have page 500, like a picture taken of it. 3 problems on page 561, which is like the review for chapter 7. So there's 3 problems on there. This is all partial fractions still. And then tomorrow we'll look at reviewing for the test on fractions. Questions? So go take a picture of the book if you don't have one. Grab a partner to work with.
500.